The camera descends through darkness, 1,000 meters down, where sunlight becomes a forgotten memory. Something ancient stirs in the void. Its body undulates like a serpent through the crushing black water, 6 frilled collars rippling at its throat. 300 needle teeth glisten in bioluminescent flashes. This is no myth, no legend conjured by sailors lost at sea. This is real. This is the frilled shark, and it has been hunting in these depths since the age of dinosaurs. On January 21, 2007, a Japanese fisherman off the coast of Shizuoka made a discovery that would send ripples through the scientific community. In shallow water, weakened and disoriented, he found a creature that shouldn't exist in the modern world, a 5-foot serpent with the face of a dragon. Staff at Awashima Marine Park rushed to capture it, placing the dying animal in a seawater pool where they filmed it for precious hours before it succumbed. The footage revealed something extraordinary, a living window into the Cretaceous period, swimming with the same body plan, the same hunting adaptations, the same primal efficiency as its ancestors from 80 million years ago. Scientists call creatures like this living fossils, but that term barely captures the profound strangeness of the frilled shark's existence. This is an animal that witnessed the rise and fall of Tyrannosaurus rex, that survived the asteroid that ended the dinosaurs, that persisted through ice ages and mass extinctions while remaining fundamentally unchanged. When you look into the eyes of a frilled shark, you are looking at a design so perfect, so precisely adapted to its environment, that evolution itself saw no reason to modify it. The story begins in the late Cretaceous, 95 million years ago, when the Earth's oceans teemed with marine reptiles and the ancestors of modern sharks were just beginning to diversify. In those ancient seas, the family Chlamydoselachiddae emerged, characterized by their eel-like bodies and primitive features that set them apart from other sharks. Fossil teeth found in deep-sea sediments tell us these sharks have always been creatures of the abyss, dwelling in the same dark territories their descendants occupy today. While their relatives evolved into the sleek predators we recognize as modern sharks, the frilled shark's ancestors found their niche in the deep and never left.
What makes this survival even more remarkable is what happened to the world around them. The Cretaceous ended in fire and darkness when an asteroid struck the Yucatan Peninsula 66 million years ago. 75% of all species vanished. The oceans acidified, surface temperatures plummeted. Yet far below, in the cold, stable darkness of the continental slopes, the frilled shark's ancestors endured. The deep sea became their sanctuary, a realm of such consistent conditions that rapid evolution was unnecessary. While the surface world transformed repeatedly, these sharks remained virtually unchanged, perfecting rather than reinventing their ancient design. Imagine encountering one in the flesh. The body stretches to 6.5 feet, chocolate brown or gray, moving with the sinuous grace of an eel rather than the lateral motion of typical sharks. The head is flat and broad, with a rounded snout that gives it an almost serpentine profile. But it's the gills that truly arrest your attention. 6 pairs instead of the 5 found in modern sharks, each with elaborate frills of tissue extending beyond the gill slits like a Victorian collar. That first pair connects continuously across the throat, a feature unique among all living sharks, giving the creature the appearance of wearing some elaborate necklace from a forgotten age. The mouth, positioned at the very end of the head rather than underneath as in most sharks, can open wider than seems physically possible for a creature its size. Inside, arranged in approximately 25 rows, are 300 trident-shaped teeth, each one curving backward like a fishhook. These aren't the serrated blades of a great white designed for tearing flesh. These are gripping instruments, precision tools for snagging soft-bodied prey in the darkness. Each tooth has 3 elongated cusps separated by 2 smaller intermediate points, creating a treble hook configuration that once it catches something, rarely lets go. Scientists examining preserved specimens have noted something peculiar about these teeth. They're remarkably bright, almost luminescent white against the dark interior of the mouth. This has led to a fascinating theory. In the absolute blackness where frilled sharks hunt, those pale teeth might serve as lures, attracting curious prey toward what appears to be bioluminescent food, only to find themselves ensnared in an inescapable trap. Observers have noted that captured frilled sharks often swim with their mouths hanging open, a behavior that might maximize this deadly deception. The deep ocean where these sharks reign is not merely dark, it is a cathedral of pressure, where every 10 meters of depth adds another atmosphere of force pressing inward from all directions. At 600 meters, the frilled shark's typical hunting ground, the pressure exceeds 8 million pascals, roughly 600 times the air pressure at sea level. This is equivalent to having a truck resting on every square inch of your body. Yet the frilled shark glides through this crushing environment with ease. Its body is a masterwork of biological engineering for extreme depths. A massive liver filled with low-density oils and hydrocarbons makes the shark nearly neutrally buoyant, allowing it to hover motionless in the water column without expending energy to maintain position. This is crucial in an environment where food is scarce and every calorie must be conserved. The cartilaginous skeleton, lighter and more flexible than bone, bends rather than breaks under extreme pressure. The skin, thick and elastic, maintains internal pressure equilibrium. Every organ, every cell has adapted to function under conditions that would instantly kill surface-dwelling creatures. The darkness here is absolute. At these depths, no photon of sunlight has penetrated for millions of years. The only illumination comes from bioluminescence, brief, ghostly flashes of blue-green light produced by desperate prey trying to confuse predators, or by predators themselves using light as a lure. In this alien realm, vision, as we understand it, becomes nearly useless. The frilled shark's eyes are moderately large, suggesting it can detect those rare flashes of bioluminescence, but its primary sensory system lies elsewhere. Running along each flank is an open lateral line, a channel filled with specialized cells that detect even the faintest vibrations in the water. Where most sharks have these sensory organs enclosed beneath the skin, the frilled shark's channels remain exposed, possibly making them even more sensitive to the minute pressure changes created by swimming prey. This system is so refined that the shark can sense a squid pulsing 50 meters away in complete darkness, tracking it not by sight or sound, but by the displacement of water molecules. The hunting strategy that emerges from these adaptations is something between science and nightmare. Picture a frilled shark drifting motionless in the midnight zone, its oil-filled liver keeping it suspended in the water column like a ghost. Its open lateral line detects vibrations, a squid, exhausted after spawning, drifting weakly in the darkness. The shark's body begins to move, not with the side-to-side motion of typical sharks, but with the vertical undulations of a sea serpent. Scientists theorize, based on body structure and the limited observations available, that the frilled shark employs an ambush strategy unlike any other shark species. It coils its elongated body like a compressed spring, bracing its rear-positioned fins against the water or a rocky outcrop for leverage. Then, with explosive force, it launches forward in a strike that resembles a cobra more than a fish. The wide-opening jaws engulf prey up to half the shark's own length, and those backward curving teeth ensure there is no escape. Some researchers have proposed an even more unsettling possibility. The unusual structure of the frilled shark's gill slits, with that continuous first slit across the throat, might allow the animal to create negative pressure inside its mouth cavity. By rapidly closing its gills, it could generate a powerful suction, literally vacuuming prey directly into its jaws. This would be a hunting method seen in no other shark species, a technique refined over millions of years of deep-sea predation. The diet reveals the shark's position in the abyssal food web. Stomach contents of captured specimens contain primarily deep-sea squid, species that themselves never see sunlight, creatures with bodies like translucent silk and eyes the size of basketballs. Bony fish adapted to extreme depths appear frequently, along with smaller sharks that share the frilled shark's lightless realm. Occasionally, evidence suggests these sharks may scavenge on marine snow, the constant rain of organic matter from the surface, including the occasional whale carcass that drifts down to the seafloor.
But perhaps the most extraordinary aspect of the frilled shark's biology is its reproduction, which represents an adaptation to scarcity so extreme it defies comprehension. Female frilled sharks carry their young for up to 42 months, 3.5 years of pregnancy. This is twice the gestation period of an African elephant, and by far the longest known for any vertebrate on Earth. Think about what this means. A female frilled shark becomes pregnant, and for the next 3.5 years, she hunts the abyss carrying developing young inside her body. The embryos, enclosed in golden brown egg capsules, remain within her uterus, feeding on enormous yolk sacs. They grow at a rate of just 1 to 1.5 centimeters per month, slow even by the standards of deep-sea life. When finally born, the pups measure between 16 and 24 inches long, fully formed miniature versions of their mother, ready to begin hunting immediately in a world where parental care does not exist. This reproductive strategy is both a survival mechanism and a vulnerability. In the stable environment of the deep sea, where conditions change little over millennia, slow reproduction works because adult mortality is low. Predators are rare at these depths. Disease is uncommon in the near-freezing water. A frilled shark that survives to adulthood might live 25 years, reproducing only a handful of times and producing just 6 pups on average per litter. This is the life strategy of a creature so well adapted to its environment that it doesn't need to reproduce quickly, until something disrupts that ancient equilibrium. The frilled shark's existence remained unknown to science until the late 19th century. German ichthyologist Ludwig Doderlein collected the first specimens during 3 years of marine research in Japan between 1879 and 1881. He recognized something extraordinary in these strange eel-like sharks and brought 2 specimens back to Vienna. But tragedy struck. Doderlein lost his taxonomic manuscript, and the formal description of the species fell to Samuel Garman. In 1884, Garman published his observations in the Bulletin of the Essex Institute, describing a shark unlike anything in the known taxonomy. He classified it in its own genus and family, naming it Chlamydocelicus anguineus, the eel-like shark with frills. The Greco-Latin nomenclature captures the creature's essence: clammy for frill, celicus for shark, anguineus for eel-like. Garman initially proposed the frilled shark was related to Cladocelici, ancient sharks from the Devonian period 350 million years ago, though later research has refined this placement. For over a century, frilled sharks remained scientific curiosities, known only from occasional specimens hauled up in the nets of deep-sea trawlers. Each capture provided new data, but living observations were impossible. These sharks cannot survive in captivity. Brought to the surface, they quickly weaken and die, unable to adapt to the dramatic pressure change and the relative warmth of shallower water. Every attempt to study their behavior in aquariums has ended the same way. Within hours, the animal expires, leaving researchers with more questions than answers. Then came January 2007, and that moment off the coast of Japan when a fisherman spotted something that shouldn't have been there. The female frilled shark, 5 feet long, swimming weakly in shallow water. Marine park staff moved quickly, capturing the animal and placing it in a seawater pool. For a few precious hours, they filmed it as it swam, its mouth opening and closing, revealing those rows of trident teeth. The footage, grainy but extraordinary, shows the creature's serpentine motion, the undulation of its long body, the alien beauty of its 6 frilled gill slits. Modern technology is slowly revealing more.
Deep-sea submersibles equipped with high-definition cameras occasionally capture footage of frilled sharks in their natural habitat. These glimpses show animals seemingly floating motionless in the water, their bodies hanging vertically or draped over the terrain. The first such footage was recorded only in 2004, and encounters remain rare enough that each new sighting generates scientific excitement. We're slowly building a picture of how these sharks actually live, but the picture remains frustratingly incomplete. One of the most intriguing aspects of frilled shark biology is their primitive jaw structure. Unlike modern sharks, where the jaws are suspended beneath the skull by strong ligaments and muscles, the frilled shark's jaws connect directly to the cranium at a point behind the eyes. This is called amphistyle, and it's the same arrangement seen in ancient extinct sharks. It gives the frilled shark a relatively weak bite compared to species like great whites or tigers. They're not designed to crunch through bone or tear flesh. Instead, those hundreds of backward curving teeth are meant to hold on, to prevent slippery squid from escaping while the shark swallows them whole. This feeding strategy explains another peculiarity: the frilled shark's exceptionally flexible jaws. They can open their mouth wider relative to body size than almost any other shark, allowing them to consume prey nearly as large as themselves. In the deep sea, where meals are few and far between, the ability to take advantage of any opportunity, even if it means swallowing something enormous, becomes crucial for survival. In 2009, scientists described a second species of frilled shark, Chlamydoselachus africana, found off the coasts of southern Angola and Namibia. This southern African frilled shark differs from its better-known relative in subtle but consistent ways: longer head, shorter gill slits, fewer vertebrae in its spinal column, and fewer turns in its intestinal spiral valve. The discovery suggested that frilled sharks, while widely distributed, might consist of multiple species isolated in different ocean basins, each adapting slightly to local conditions while maintaining the overall body plan that has served them so well. The existence of these parallel species raises questions about how frilled sharks disperse. They live on continental slopes, following the contours of land masses beneath the sea. Population genetic studies suggest limited gene flow between Atlantic and Pacific populations, implying these sharks don't regularly cross vast stretches of open ocean. They're tied to the margins, to the places where continental shelves drop away into the abyss, following these boundaries like roads through the darkness. As we push deeper into the 21st century, the frilled shark remains a symbol of how much we still don't know about our own planet. More people have walked on the moon than have seen a living frilled shark in its natural habitat. We've mapped Mars in higher resolution than the ocean floor. The deep sea, which covers more than half of Earth's surface, remains less explored than any other environment. And in that vast darkness swim creatures like the frilled shark, carrying in their bodies the accumulated wisdom of 95 million years of survival. Each new piece of information we gain about these animals reveals not answers, but more profound mysteries. How do they find mates in the darkness across such vast territories? What triggers them to begin their vertical migrations? Do they have social structures we've never observed? How does that 42-month pregnancy actually work? What hormonal and physiological mechanisms sustain it? Why did evolution preserve this particular form with such fidelity while allowing other shark lineages to diversify dramatically? The frilled shark forces us to confront uncomfortable truths about conservation. How do we protect a species we can barely study? How do we regulate fishing at depths where we can't monitor what's actually being caught? The deep sea has long been treated as an inexhaustible frontier beyond the reach of human impact. But trawling technology now reaches a mile down. Climate change is altering temperature and oxygen levels even in the abyss. Pollution sinks to the deepest trenches. No place remains untouched. Perhaps the most valuable lesson the frilled shark offers is perspective. When we look at the challenges facing humanity, climate change, resource depletion, technological disruption, it's easy to feel like we're facing unprecedented crises. And we are, from a human perspective.
But the frilled shark has survived events that make our current troubles look small. It survived the KT extinction. It survived ice ages. It survived volcanic episodes that covered continents. Not through ingenuity or adaptation in the usual sense, but by finding a niche so perfectly suited to its abilities that external catastrophes became irrelevant.
The frilled shark teaches us that survival sometimes means retreating to the depths, both literal and metaphorical. It means finding the places where external chaos cannot reach you, where conditions remain stable enough that your particular set of adaptations continues to work. It means accepting a slow life, a patient life, a life measured not in years, but in epochs. On some dark continental slope right now, a female frilled shark is beginning her 3rd year of pregnancy. Inside her body, embryos the size of pencils are slowly growing, feeding on yolk that will sustain them until they're large enough to be born into the crushing darkness. They will never know their mother. They will never see sunlight. They will spend their entire lives in a realm of cold and pressure and eternal night, hunting prey their ancestors hunted when Triceratops walked the earth. And somehow, impossibly, this ancient pattern will continue. The frilled shark will glide through the abyss, sensing vibrations with its exposed lateral lines, coiling its body in preparation for the strike, opening wide that mouth full of 300 fishhook teeth. It will hunt and eat and mate and reproduce just as it has for 95 million years, carrying forward a design so perfect that time itself saw no need to change it. We call them living fossils, as if that captures what they are. But the frilled shark is not a relic. It is not a remnant. It is a master of its domain, as successful in its niche as any apex predator has ever been. It has outlasted countless species that were supposedly more advanced, more evolved, more fit. It has survived by being exactly what it needed to be and nothing more. A patient hunter in the dark, a dragon of the abyss, swimming through time unchanged and unchanging. As the ocean depths continue to reveal their secrets, and as technology allows us glimpses into realms that were once beyond reach, we may finally understand more about these extraordinary animals. But perhaps some mysteries are meant to remain. Perhaps the frilled shark, swimming in darkness so complete that our minds can barely comprehend it, should keep some of its secrets. In a world where we've mapped and measured and cataloged almost everything, there's something profound about knowing that dragons still exist in the deep places of the world, beyond the light, carrying in their bodies the memory of the age of dinosaurs. The frilled shark endures, and in its endurance it reminds us that success isn't always about change and adaptation and progress. Sometimes it's about finding your depth, your darkness, your perfect pressure, and holding that position with absolute commitment for as long as the world allows. 95 million years and counting. The dragon of the abyss swims on.